Good morning, everybody, and welcome to this next episode of our webinar series, Starburst in Action. My name is Corby. I'm running the Solution Architects practice here in Europe, and we have an exciting new topic today where Patrick Plejo from Tatra Banka will share their journey on modernizing their Hadoop infrastructure to Starburst. A few logistical hints. You see a chat window on the top right of your screen. Please use that anytime to ask questions and we'll try to answer them immediately. Or if they are directly directed towards Patrick, we'll do that in the Q&A session at the end of the webinar. We'll plan for 25 to 30 minutes. So if you're in Central European time zone, you should definitely be back for lunch at 12 o'clock, as we used to do that in Germany. So without further ado, I'm handing it over to Patrick and wish you all a good time.
Thank you, Corby. So hi everyone, and let me share our journey from Hadoop to Starburst in Tatra Banka. So let me first tell you what are we going to talk about today. So I will do some introduction about me and about Tatra Banka, and then about our journey since like 2019 up until this day. So something about me. My name is Patrick. I'm enterprise architect in Tatra Banka. I'm responsible for data area. What does that mean? I'm basically responsible for data architecture, data management, improving data quality, and also focusing on latest technology in data area. Something about my background. I have almost 10 years of data processing experience, mostly in the world of SQL, so basically Oracle, SQL Server, or Postgres, and also in the past 5 years in big data ecosystem, mostly in Hadoop, in Impala and Hive, but recently a lot of experience in Trino and of course in Starburst. My passion is SQL optimization. What does it mean? I love to optimize all the processes regarding database, basically compression, partitioning, subpartitioning, indexes, so everything about the data layout, and of course optimizing SQL queries by using some hints or rewriting them completely. So that was about me. What about Tatra Banka? Tatra Banka is a bank in Slovakia. It's part of the Raiffeisen Bank International. We currently have over 1 million of customers in a country of 5.4 million people. So we are quite large bank in Slovakia, but not as large in terms of the world stage. What is our, I think, specialty is that we have a high variety of financial services products, which means we are quite complex. We don't serve only the retail clients, we serve a lot of other clients also, and we do asset management, we do private banking, leasing, insurance, pension funds, investments, and also many other things. So that was something about me and Tatra Banka. Let's deep dive into our data platform. So we start in the year 2019, or actually years up to 2019. The whole data platform in Tatra Banka was all around one technology, and it was Oracle database. It was a single node database, big enough to process all the data we needed, but not too big enough so it wouldn't be expensive. In this Oracle database, we currently process over 100 data from over 100 of applications, and the whole Tatra Banka history is stored here. And as I said before, I like optimization, so also this Oracle database is highly optimized. Everything is partitioned, indexed, compressed, etc. Who are the users of this data platform in Tatra Banka? So, as I said, it's a central analytic platform for Tatra Banka, so everyone from reporting to analytics, compliance, applications, so basically risk reporting or risk analytics, finance, controlling, retails, or even sales reporting. Basically, there is not a single person who wouldn't be in touch with this data platform in any way. Even the people on branches, their sales reporting, how much they sold, is calculated and reported from this data platform. But it is good. The Oracle platform is good and was good, but it has its own challenges. And what are those? Those are two pain points that we had is actually storage. It's on-premises database. You cannot scale storage easily on on-premises, and that's one thing. And second thing, for the Oracle database, it's a relational database. Relational database storage is expensive. And second pain point that we had is performance on large data sets. So we either ran analytics for a long time, 1 hour, 2 hours, or 3 hours, and if you have 8 hours in a working day and you want to do a lot of analytics, and if it takes too long, it's not a good thing. And second thing, there were some analytics that we were not even able to run. So that leads us to year 2019. What was the solution number one? In 2019, we introduced new platform to our ecosystem, and it was Hadoop platform. You know, the Hadoop is like, in the Hadoop there are a lot of components. Our query engine in the Hadoop ecosystem was Apache Impala. And this gave us new possibilities. What were the new possibilities? So basically new analytics and new use cases on top of Impala. And also we migrated part of our Oracle load from Oracle to Impala. Why? Because the load that was in Oracle wasn't actually suited for Oracle. It was much faster in the Impala and cheaper to run in Impala, and we reduced a little bit of data in the Oracle. But I think a lot of you know the old Hadoop world that was built on top of Hive table format. It had its challenges also. First challenge was data integration. For migrating data from Oracle to Impala or to HDFS, we used Scoop, which is another library that we had to use. It wasn't, or even it's not even supported anymore. It's not developed anymore, and it was a bit complicated to use sometimes. In the old Hadoop ecosystem, we had the storage and compute coupled. So basically, if we wanted more storage, we also needed to buy more compute, vice versa. We were not able to upgrade this platform. And the most important two pain points were actually the very limited and slow DMLs. So basically, the only DML in the Impala that we had was override the whole table, which is slow and limited, and also limited partitioning in the old Hive table format. There were two things. Limited partitioning is one thing, that you had some limits, but also you had some limits in terms of number of partitions. When you have too many partitions, then your queries will become slow. And we try to find some ideal ratio for this, not to get too many partitions. Then year 2020 came. We were quite happy with our Hadoop ecosystem, but in 2022 we were looking into new directions, or we had to look into new directions. Why? Because in Tatra Banka the cloud strategy was introduced, basically. And the Hadoop infrastructure, which was bought in 2019, had to expire in 2024. You know, in big enterprises, when you buy on-premises infrastructure, you have to replace it every 5 years. So we started to think what we should do. One thing we can do is to replace the Hadoop ecosystem one-to-one, but the 2022 or the current Hadoop that we had, it was inefficient to migrate it to the cloud. And it was inefficient to replace the on-premises infrastructure. So basically, then we had two things that we could do. Replatform the Impala, that would solve some of our pain points or complete replatform. What would Impala solve, for example, is a partially DML, slow and inefficient DML, and decoupling, because we would decouple the Impala from HDFS to Impala to have to read data from S3, but we still would have to find a new application to migrate our data from Oracle to Impala. And the final solution, or the final solution, was to completely replatform our data platform. Why? Because if we are going to do big change, do the change as big as possible or as good as possible without looking at the size of the platform. So what we were looking into. So basically we had several issues. First issue was storage. So if we wanted to move into the cloud in the future and use some modern storage, we didn't want to stay on HDFS. We wanted to move to object storage. Okay, so we were like, okay, we have to find a solution that is object storage compatible, but not compatible, ideally object storage focused, centric. Impala was HDFS centric and object storage compatible. We were looking for a solution that's very good and very fast with large analytics. Impala was good for that. We use it for that. And other tool that we looked into was a Starburst Enterprise. So basically, we were looking into many tools, but one of the tools that was sufficient for us and good enough for us was Starburst. Another thing that we wanted to get rid of is Scoop and find some tool that natively supports I would call it batch integration. Someone calls it data federation, and Starburst does this pretty well with the connectors that it has. And actually we use Oracle connector to migrate data from our Oracle to Starburst. And we were looking for a tool that has very good DML support. And basically in 2022, new words like Iceberg, Delta, etc. Were coming out. Starburst had very good, I would say, even one of the best Iceberg integrations out there. For example, Impala, in the time when we were looking for the new platform, had very limited support for Iceberg. It could only read Iceberg v1 tables, where Starburst had much better integration with Iceberg. I think already updates were in play those days. And the last thing that we were looking to is to have a tool that's very similar to our current Oracle/Impala setup. What does it mean? We are SQL-centric company. What does it mean? Our ETL jobs, our engineers, our analysts, our data scientists, all of them use SQL. So to look for some tool that's SQL centric, and that Starburst is. It's called Postgres for Analytics, so its SQL support is perfect. Why did we go actually with Starburst and not with some open source solution, etc.? Starburst provided with some extra features that we were looking for. As you can see on the left side, security is one of the big part why we choose to go with Starburst. We are very security aware bank, and one of the first things we were looking into were minimal image builds from Starburst. Basically, if you would use the Trino open source with all of its connectors, you would have to use all of the connectors which have CVS in it, and we wanted to reduce CVS to bare minimum. So basically, we use only connectors that we need in Tatra Banka, and our image has only like 6 connectors. Second thing is the role-based access in Starburst, which is very easy and friendly to implement. Is actually we could implement the same role-based access that we have in Oracle into Starburst. So basically, there's nothing new for our data engineers or even data analysts. They don't have to learn anything new. So basically, all the data access rules are same as they were before. And Starburst backend database, which is for us, it's a Postgres backend database, which has all this who accessed what table, what data, when, how. It's very good. I like it. And also we needed to use LDAP group provider because in LDAP we store all of our access rights, and we didn't want to master those access rights in the backend database. We wanted to federate those rights from LDAP. And two very good utility tools is the Starburst UI, which is great for quick prototyping. If you don't want to get up and running your Python or your dbeaver, you can easily go into Starburst UI, and it's very good for admin usage. And also for the support, because we are a bank, we are not a technology company. We need some strong partner for this, who is responsible for providing the best and for the best possible image that's possible. Okay, what about our big data architecture? How did it look and how did it change in the meantime? So basically on the top part, you can see our big data architecture up until year 2024. On the bottom side, you can see the current big data architecture. And right now, the architecture is much more simplified. Before that, we are using our internal orchestrator. It's called DVH Engine. And in the old Hadoop ecosystem, we had to use Apache Airflow just as a utility tool, not as an orchestrator tool, just to run scoop jobs, which would query the Oracle database, store the data in the Hive format in the HDFS, and then the Impala had to read the imported files and insert it into the Impala storage. And from Impala, there were many users. These days, we have a DVH engine connecting directly to Starburst, which basically reads the data from Oracle and stores into Starburst tables or Iceberg tables, which are ready for analytics and reporting right away. And that's basically it. Just to be how to say it? Just for information, we still use Oracle for processing and for reporting, but big data reporting and big data processing is done on top of Starburst. So, how does our current deployment look? On the left side, our current storage on top of S3 is 15 terabytes. So as I said before, we are not too large of a bank in terms of in the stage of the world, but we are complex enough, and these 15 terabytes is with the 1 or 2 days worth of snapshots in Iceberg. Actually, if we compare this data to our Oracle and the data that's in the Iceberg on the S3 is compressed 10 times better than in Oracle. Right now, for the compute, we use 4 R7i X large machines. What does it mean? It's like 120 vCPUs, and I think it's 1 terabyte of RAM. We plan to increase this by 50% in like 2 months. And right now we don't have any scaling, which we want to introduce in upcoming months. And regarding of the data, the Oracle is big part of our processing. The main part of the data is processed there, and 60% of the processed data in Oracle is synced daily to Starburst to be ready for analytics and reporting. Right now, we run approximately 7,000 queries per day in Starburst, and by query, I mean any query that reads data and takes some time. So basically, no metadata queries or no optimized queries are involved in these 7,000 queries. And we have we migrated approximately 10% of users are using Starburst mostly these days. What we are planning to do in future, so basically move to ARM CPUs. As I said before, scaling is something we want to do in future, and we want to do more integrations. What does it mean, more integrations? So basically, in the old Hadoop ecosystem that we had, we couldn't integrate properly with other applications because we had very limited possibilities. Thanks to connectors that Starburst provides, we can integrate much more easily with solutions that use either object store or other databases. And what are our, I would say, achievements against the old Hadoop ecosystem? Right now, we use much less vCPUs than we used to use. Basically, we moved from 700 to 120. We have twice the better the compression that we had before. So yeah, much less data used, and it's on top of S3, so it's cheaper. We are using much less RAM. Regarding RAM, Starburst is a memory-hungry application, it's Java application, but thanks to this, it's also very fast. And we are using, if you can see, R machines, which are the memory-optimized machines. And still we are using less RAM than we used to on the old Hadoop ecosystem. And thanks to the SQL nature of the Starburst, that we can do everything in SQL, so we don't have to use Scoop or any other tool. The development is much faster. And I'm not sure, but yes, this was my last slide. And
Patrick, thank you so much. Thanks for the insights. There are a few questions in the chat. I'll let you read through them before I'll pick them up. Before we do that, I'll give a few takeaways that I took from your presentation. First of all, thanks for this very concise presentation. You achieved a simplified architecture, so you got rid of a couple of technologies in the Hadoop ecosystem. Scoop, no more internal orchestrator, no more Airflow, no Impala. Instead, you reduced and consolidated everything to Iceberg and Starburst, which is great. Then I noted you just had that in your last slide, lower infrastructure footprint. So you saved up to 5 times the costs for your compute. Better performance in general and interoperability. You mentioned the connectors that we have that allows you to integrate to other systems faster and better, and a perfect SQL support. We could see that it's fit for purpose for a Hadoop replacement. And easily fit into your existing infrastructure. We can probably go into that with the questions as well. And security was a key driver, and that's something we also see across the industry when it comes to why people choose Starburst, is especially in the financial services industry where there is a high need for a very secure environment. Starburst is always a very good choice. So getting into the questions, and I'm a bit conscious of time, but we have about 5 minutes to answer this.
Okay.
There was a question around how you actually conducted the migration, how you validated your migration from your previous common data platform to Starburst, and how you tested it in the POC and compared it to Hadoop. Are there a few details that you can share on that?
Yeah, there were actually several steps. First of all, we conducted a wider market research. So basically, we looked into more tools. Then we narrowed it down. First validation was looking to documentation deep into Impala, Starburst, and other tools. Then we used some free free available SaaS solution to just test some functionalities. For example, for Starburst, we tested Starburst Galaxy for several hours, and then we built a POC infrastructure in Tatra Banka to test some functionalities more in depth. So basically it was like 3 or 4 steps: market research, documentation research, use free credits on top of some SaaS solution, just to be sure that it provides us our basic capability needs, and then POC built in our infrastructure.
Thank you very much. The other question there was more in the area of real time. Starburst is often used for real time, or at least near real time, analytical use cases with our connectivity to engines like Kafka, for instance, but others as well. Is there anything that you are planning to do or that you have done already in terms of real time analytics on top of the Starburst architecture?
Not these days, actually, because we had the old Hadoop infrastructure, which didn't have this capability. And in Tatra Banka, we do not do a lot of the real-time big data analytics. We did not do until these days. We are looking into that actually these days, but it's just in the beginnings. Like, we are not going to do that in the next 6 months.
Got it. Okay, cool. Thank you very much. I know it's been a very fast journey with you as well. Within a few months, you've actually managed to go into production after we facilitated the relationship to Tatra Banka, and happy to see that grow and succeed in the future as well. Talking about future, what's next? Our next series in this webinar is going to be again about modernizing the data lakehouse at Checkatrade. The approach is a bit different, and George Karapalidis, who is director of data at Checkatrade, is coming a bit more from the business side. So if you're interested on how Checkatrade achieved their benefits with Starburst as well, make sure to sign up, use the QR code here on the screen, or if you miss it or don't have your phone with it, go to the Starburst website and to the events section. Make sure to sign up for it now. It's going to be a very concise 25 to 30-minute webinar again, not taking too much time out of your diaries, but hopefully providing a lot of value to you. Thank you, everybody. Thank you, Patrick, and wishing you a great day. And to those who have a public holiday tomorrow, a very nice public holiday, or maybe even an extended long weekend. Thank you.
Thank you.